Now the power transmission and gearbox of the tractor. Myself, Professor Shinde, working as assistant professor in Kekewa College of Agriculture Engineering and Technology, Nashik. Now, powertrain of the agriculture tractors, how transmit the power from engine to the rear wheel of the tractors. You can see the power produced in engine cylinder and it is given to the clutch to gearbox and differential system to the final drive and rear axle and rear wheel of the tractor. Now the basic function of the power transmission system to transmit the power from engine to the rear wheel of the tractor. Second, to make the reduce the speed available to rear wheel of the tractor. Operating speed of the agriculture tractor in 3 to 6 kilometers per hour. To alter the ratio of the wheel speed and engine speed in order to suit the field condition. Now we can see the how the gear torque and speed relationships. You can see when speed is increased, the torque is decreased, and speed is decreased, the torque is increased, vice versa. So the general requirement of the tractor required the less speed and high torque at the rear wheel of the tractor. Now these are the types of the gears. You can see the different types of the gears: spur gear, helical gear, bevel and pinion gears. Now the gear ratio, when two shafts are connected by gear, the ratio between the speed of this shaft will be always constant, and this constant ratio is called the gear ratio. And we can know that the speed of the driver upon speed of driven is equal to number of teeth present in a driver driven upon number of teeth in driven. Now the gear design consideration: pitch diameter of spur is determined by the following equation. The load on the gear tooth is given by Ft2T by D, where T is the torque transmitted in Newton meter, D is the pitch diameter in millimeter or meter, N is the RPM of the gear or shaft, and Vm is the pitch line velocity meter per minute. Now helical gear, it is a tangential force, act, pitch diameter, thrust force and separating force. In the general range of the tooth model, forward is given in driver train, the transmission gear 4 to 5, and power shift planetary gear 2.5 to 3.5, spiral bevel gear is 8 to 12, and final drive is 5 to 7. Now these are the three types of the gear generally: sliding mesh types of gearbox, constant mesh and synchro mesh types of gearbox. The sliding mesh types of gearbox, it has a two parallel shaft, the gears mounted on each shaft. The gears on the lay shaft or counter shaft are fixed, and the gears on the main shaft are slide on the shaft. So at the shifting of the gear, we can use the shifting rail to shift the gear from one position to the another position. We mesh the gears on the main shaft to the counter shaft or lay shaft. Now the constant mesh types of gearbox, you can see the view of the constant mesh types of gearbox. Generally it is the both shafts are parallel to each other, main shaft and counter shaft. The gears on the main shaft and counter shaft are constantly meshing with each other. Now the synchro mesh types of gearbox, the synchro mesh types of gearbox, the synchronizer, it is the types of the constant mesh types of gearbox, but additional device like a synchronizer device is used. Additional device is used to mating the speed, to equalize the speed before mating the gears. These are the two block rings used, then synchronizer sleeves, and then lock rings and insert locks and hubs. These are the synchronizer in neutral before shift. Now what are the merits and demerits? Sliding mesh of gearbox is highly efficient, economical and simple in design. Demerit of the sliding is a difficult shifting of the gear, need to slow down the speed whilst changing the gear. A noise in operation require a high skilled driver to change the gear. Now constant means gearbox merits are less noise in operation, less shifting effort, and demerit of constant mesh gearbox less efficient than sliding mesh gearbox. Double declutching is required for changing of the gear, which cause fatigue of the driver. Synchronous gearbox, the noiseless gear changing, smooth gear changing, and less vibration. And demerits are initial cost is high, more space is required, and precise operation is required. Now the transmission efficiency is calculated by this formula. You know, the T is the engine torque, N is the engine RPM, T sub W is the driver wheel torque, N sub W driver wheel, and transmission efficiency denoted by. These are the speed reduction in joint years. Now the transmission system in the different tractors. You can see the related engine speed, the numbers of speeds, 8 forward to reverse. It's a John Deere 8 forward to 4 reverse, Sonalika 8 forward to reverse, Massey Ferguson 8 forward to reverse, Farm Track 8 forward to reverse. And forward speed may be according to 0.9 to 30 km per hour as well. Now the reverse speed is 4 to 11.9, 3 to 14, and 15. Now the final drive ratio of the different tractors. You can see it vary from 6:1 or 5:1. These are the gear reduction ratio in tractors from engine drive to final drive. You can see the gear reduction ratio is 1.12 or 1.1:6 to 1:15. Now the final reductions is called as the final reduction: bull gear, pinion gear, planetary, and big crown wheel. The causes further the reduction in speed and increase the torque. These are the bull gear or pinion gears reduction in a different housing. It is also called as the speed reduction mechanism. Load comes on at one point on driver parts. The noisy operation require more space, isn't it? Now the big crown wheel, you can see the more effort is required for braking. The planetary reduction, equal distribution of the load on each gear and axle, longer life of the gear and axle, compact and quarter operations, electric design being used the world over. Now these are the planetary drive system. Thank you very much.